we're going to start with the substitution method. Substitution method, the first thing you need to do is have one of your equations as the variable equals everything else. So here, my equation number 1, because I like to label them, equation number 1 is a variable equals everything else. So that makes it really easy to do this, because now all we've got to do is we can see that y here equals 6x plus 5. But we know if we have our two graphs crossing over, they have the exact same y value. So that means this y and this y are the same thing. And if these two y's equal the same thing, and that y equals 6x plus 5, we can just substitute that straight into this equation. So we're going to sub equation 1 into equation 2. So now we have 6x plus 5 minus 3x equals negative 4. And by doing that substitution, I get rid of my y variable, so now I only have to solve for 1, which is a really easy thing for us to do. 6x minus 3x, we've got 3x plus 5, then we take 5 from both sides, then we divide both sides by 3. So we can see for these points, when they cross over, our x value would have to be negative 3. So we haven't really graphed it, but we know we've got two lines that cross over and their x value is negative 3. Now we need to find their y value. So I would sub that x value into either of your equations. When you're doing substitution, it's generally easiest to go into that variable equals everything equation, because you're not going to have to do any rearranging. So we're going to sub into 1. So y equals 6, negative 3 plus 5. So we get to y equals negative 13. So our point of intersection, where these two cross over, is negative 3, negative 13. And that's as easy as substitution method is. I have another one here, but I think it's really ugly. So we're going to skip it. Actually, we might just change it, make it a slightly easier equation. Let's go 2x plus 4y equals 5. It's still going to be ugly, but the numbers should be smaller. So for the substitution method, remember our first step, we need to have equation, a variable equals everything else. And we don't have that here yet. So what we're going to do is rearrange one of our equations. I'm going to rearrange equation 1. So that's going to become y equals 4 minus x. And that's now my equation 3. And I'm going to sub equation 3 into equation 2. Make sure once you've rearranged it, you don't sub. So my equation 3, I would not be able to sub it back into equation 1. Not going to work. Going to get real confusing. If that happens, you know you've subbed it into the wrong spot. But now I have my variable equals everything else. I can sub that into my other equation. So 2x plus 4 minus x equals 5. Done. Now I just need to rearrange. So 2x plus 16 minus 4x. Simplify, so we get negative 2x plus 16 equals 5. Take 16 from both sides. Negative, don't you love when your brain freezes? Negative 11. Yep. And then we're going to divide both sides by negative 2. So that is an ugly answer for our x value, but that's what it is. And then we sub x back into one of our equations. We're going to go into 3. So y equals 4 minus negative 11 on 2. Going to need to turn that 4 into a fraction on 2 so that we can actually do the addition. 8 on 2 plus 11 on 2 because that was a minus 11 on 2. So y equals 19 on 2, which is an ugly answer, but that is our point of intersection for those two. So now you can go into chapter 1C on page 16 and do question 1.